stoichiometry. Stoichiometry. All right, what's the meaning of stoichiometry? You can understand it. It means exactly calculation. The meaning of stoichiometry means calculation, ratios of combination, or actually calculation related to the ratios and so on and so forth. So this chapter is going to be mainly about doing some calculations related to chemistry. All right. And when we say molecular formula, what's the meaning of molecular formula? What's the meaning of molecular formula? Is to write the structure like this is the molecular formula for H2O. This is the molecular formula for NaCl and so on and so forth. Now, I want you to get your periodic table. Get your periodic table with you, available and handy. Okay. In the periodic table, what you see here, the periodic table that I gave you, there is the element like this, and then this is a number, and then this is also a number. What is this number? What?
Atomic number.
Atomic number.
Atomic number. You have to know this. Atomic number. What is this number?
Mass number.
No, wrong. It's not mass number.
Average mass.
Average mass.
Mass. Not mass number, but it is
Atomic mass.
average mass. Yes.
Atomic mass.
Average mass. What's the unit that we have for it?
AMU.
One atom.
AMU.
Yes. AMU. What's the meaning of AMU?
Atom mass unit.
Atomic mass unit. Atomic mass unit. What's the meaning of average mass? Well, why do we say average mass?
For all isotopes.
All isotopes, yeah.
Yes. The average of the isotopes, how they are available naturally. Not any isotopes, but how they are available naturally. Okay, good? Okay. Now, if I want to know what's the mass, look at your periodic table now and tell me what's the mass of H2O. What should you tell me? It's 2 times what?
1.008 plus 60.
Plus 1 times 16.00 from the periodic table. What's the total mass?
18.02.
0.16.
0.16 to begin. I mean, if you want it, no problem. What's the unit?
AMU.
AMU.
AMU. Excellent. All right. Now, let's do it for an NaCl. Quickly.
One times 22.99.
22.99 plus
35 points.
Plus 1 times
0.45.
35.45.
what's the total?
58.44.
40. Yes, exactly. What's the unit?
AMU.
AMU. Keep this in mind. Very important. You have to keep this unit in your mind. AMU. AMU. Good. Very good. All right. Very quickly, tell me what's the mass of propane?
3 times 12.01.
Do it in your calculator. I want an answer. Actually, yes, 3 times 12.01 plus what? 8 times
Eight.
what?
1.008.
It's the total.
equal 44.094.
Very good. Let's do it for lithium hydroxide. Quickly.
23.949.
949. Who else got the same answer?
Yes, it's right.
Yes.
What's the unit?
AMU.
AMU.
You have to say it always. AMU. Okay. How about barium acetate? What's the mass of barium first?
10.81.
What is it?
10.81.
137.33.
Yes.
What is it?
137.33.
Very good. That's barium. Good. And then how many carbon?
4 carbon.
4.
4 times 12.01. How about hydrogen?
6.
6.
6 times 1.008. How about oxygen?
4.
4 times
16.
16.0. All right. Now add them together.
255.418.
Point what? 4? What?
378, I think.
378. By that, no problem. Do you know how to do it now? Is it easy?
Yes.
Good. Now, I will now define, there is another unit that I'm going to use, and I will use it here exactly when I say 1 mole of anything. Then I want to know the 1 mole, what's the mass? Now, my question is, what is the mass of 1 mole of C3H8? Okay, now here I'm asking about a molecule, compound. All right, now I'm asking about the same question, but I will use the word mole of C3H8, and you should tell me right away. The answer is 44.094, which is this one. But the unit, instead of AMU, you should put what? Gram. How easy?
Too easy.
Okay, 1 mole of lithium hydroxide. How many grams is this?
23.949 gram.
23.949 gram. Instead of AMU, I change the unit to gram. Okay, 1 mole of PaC2H3O2, all of this 2.
255.378.
255.378, but I say
Gram.
gram. I want you to keep this in mind and very clear about it. Here, we're talking about how much? 1 molecule or 1 atom or whatever. Here, we talk about what?
1 mole.
1 mole.
of atoms or molecule. Mole of atoms or molecules. I hope this is clear. Good. Let's move. Now, let's talk about the compound 1H2O2 molecule. What's the mass of 1H2O2 molecule? What's this called? What's the name of this molecule? Do you know it?
Dioxide.
It's called hydrogen peroxide. Hydrogen peroxide. Okay. What's the mass of this molecule?
34.016
34.016. Not enough.
gram.
No, wrong.
AMU, I mean. Sorry.
AMU.
Yes. AMU. Very good. 1 mole of H2O2 molecule.
It's 34.016.
More 34.016, but
Gram.
now we say gram, exactly. That's very important. Good. Now, I want to know what's the percentage of hydrogen in this molecule. What's the percentage of hydrogen in molecule? How can you find it?
Number of atoms.
Formula.
Do it. Look at what I'm doing here and do the same thing. Now, what's the percentage? 2 times 1.008 divided by 34.02. All right. Very good. What will be the unit for the percentage, which is this percentage?
No unit.
No
You-
unit.
Yes.
Percent.
Why?
It's a ratio we need for.
Okay. What's the percentage of oxygen in this molecule? You're going to do the same. 2 times 16 AMUO divided by 34.02 AMUH2O2. Okay, what's the percentage?
94.06.
What's the unit for this percentage? Unitless again. I want you to add these two numbers together.
100.
Would be 100.
It will be always 100. Or if you add the percentage of all the atoms, it will be always 100. So if I tell you that in a compound, in H2O, in a compound which is H2O2, I have 5.926% hydrogen. Then what's the percentage of oxygen?
94.
How do you know that?
Subtract from 100.
100 minus 5.926. Is this clear? Okay. Can I use, instead of AMU, can I use the mole? If I say, what's the percentage of hydrogen in H2O2 again? And I use here 2 times 1.008 gram hydrogen divided by 34.02 gram H2O2 times 100. Can I do that?
Yes.
Yes, we can.
Yes.
Why?
Because we have the same units.
The same.
We'll go with gram, and we're going to have 5.926%. I hope this is clear.
So, Doctor, AMU is equal to gram.
No. Ooh, no, no, no. One molecule equal to 1 mole of molecules? No, of course not. AMU is a very, very small number. I will tell you what is it equal to in a while.
Okay.
Okay, good. Next. I want you to tell me what's the mass of lithium carbonate? From your periodic table, don't look at the answer here. From your periodic table, lithium carbonate.
Uh, 73.89.
73. So the mass of lithium carbonate is 73.89. What's the unit?
AMU.
AMU. Good. What's the mass of 1 mole of lithium carbonate?
The same in gram.
73.89, exactly the same word, but now we'll put gram. Is this clear?
Yes, doctor. We don't put. I say we don't put a gram. Only if you tell us in the question 1 mole.
Exactly.
If it's not, we put the AMU.
Yes. Or instead of AMU, you can use another word, which is exactly, it's the same meaning, but it is also gram per mole. Let me give me this in a while, just a second. Now, let's have, I want you to calculate the percentage of lithium in this compound. Two times what?
The mass of the lithium.
6.941.
941. What is the unit?
AMU.
AMU.
Divide by what?
Divided by
73.
7.89.
What's the unit?
AMU.
What's the answer?
18.78. 787.
79.
79. Good percent. Okay. What's the percentage of carbon?
One times.
I need an answer.
81.
81.
Oh, no.
16.25.
16.25%. Good. Now I don't want you to calculate for oxygen right this way. What's the percentage of oxygen? It is 100 minus what?
18.79 minus 16.25.
0.79 plus 16.25.
Yes.
Give me an answer.
64.96.
Is this clear? How easy? How easy?
Easy.
Very easy. Good. Okay. Next. Before I go further, we said that 1 mole is equal to what? What's the meaning of 1 mole of anything?
Avogadro's number.
No. You are ahead of us. We are still. Let's talk. Let me give you something. NH3. What's this compound called?
Ammonia.
Very good. What's the mass of one ammonia molecule?
$17.03.
What's the unit?
AMU.
AMU. Keep this in mind. AMU. Very good. What's the mass of 1 mole of NH3?
0.03 gram.
17.03 gram.
Gram of NH3. Gram, I prefer to write gram NH3. Good. I want to give you one relation before I go further. I want to say that 1 mole is equal to this number. One mole of anything is equal to this number. This number is now called
Avogadro number.
Avogadro's number.
Avogadro's number. It's available in your periodic table. Look at your periodic table. Among the numbers that I'm giving you in the periodic table, right? The periodic table that I gave you, you must bring it with you every lecture. Okay? Can you see the number?
Yes, it is. Yeah.
It is there.
Available.
But I want you still to memorize it. Keep it in your mind all the time. It's very important number that we're going to use all the time. Okay? It's available. It's available in your periodic table, but with time you will memorize it. Good. I want now to make the relation between 1 gram and 1 AMU. Somebody asked me, 1 gram doesn't equal to AMU? The answer is no. 1 gram is exactly equal to this number of AMU. What's this number?
Avogadro.
Number. So 1 gram is equal to 6.022 times 10 to the power 23 AMU. So if I want to change this mass from AMU to gram, what should I do?
Multiply with Avogadro.
Divide by Avogadro number.
1 gram over 6.02.
Don't forget, where should I put the unit? Up, what should I write up?
1 gram.
And
1
down.
gram up. Yeah.
6.022.
And what's the unit? What will happen now?
Grams.
The unit will be, and I want you to give me an answer.
It is 2,827.96.
2.82 times 10 to the power minus 23.
Yes, it's like this. 2.82 times 10 to the power minus 23. What's the unit now?
Grams.
So what's this number?
Avogadro's number.
No, the number that I'm giving you. What's this number?
Mass in gram.
It's the mass of what?
Ammonia.
Ammonium in a gram.
Not 1 mole. This is the ammonia.
1 atom.
This is
1 molecule.
one molecule of ammonia. This is the mass of 1 molecule of ammonia. 1 molecule of ammonia in gram. And you can see this is very small number. What's this number now? Yes, this number.
It's 1 mole of the weight of ammonia.
The mass of 1 mole of ammonia. This is the mass of 1 mole of ammonia, and this is the mass of what?
Of 1 gram.
1 gram for ammonia.
No, why 1 gram? 1 molecule of ammonia.
So, Doctor, if we need to make it moles again, we need to multiply by Avogadro.
If you want, yes. But actually, as I said, you have to keep this in mind. If I want the mole of anything, I just take the mass and put the unit as what?
Grams.
Gram. If I tell you what's the mass of a molecule, only one molecule. What's the mass of one molecule of NH3? It's the same mass, but the unit is? Yes?
AMU.
AMU. Can I change AMU into gram?
Yes.
How?
By dividing by Avogadro's number.
And then you're going to have this mass. So what is this mass now?
It's one molecule of ammonia in grams.
Ammonia, but the unit is gram. But what's this mass? 17.3.
1 mole of ammonia in grams.
Ammonia, not one molecule, but 1 mole of ammonia. Is this clear?
Doctor, what do you mean by molecule?
One molecule. If you have one molecule, 1 N and 3 hydrogen atoms only. The mole, you have this number of molecules. 1 mole is equal to this number of molecules. So you don't have only one, you have 6.022 times 10 to the power 23 molecules of ammonia. Is this clear?
Yes.
Let me take this away and I will repeat everything in something else. All right. Let me take all this.
So, doctor.
Yes.
If we say 70.03, it's the mass of 1 molecule of ammonium, right?
Yes. We will repeat everything now. I will not keep even these numbers in your mind. I hope you can see your periodic table and find the Avogadro's number and everything. Let's take this all away. Okay. Let's have another molecule, completely different molecule. H2SO4. Okay, I want you to tell me that now. What's the mass of one molecule H2SO4? Go to your periodic table, give me an answer.
.086.
What's the unit?
Gram.
No.
AMU.
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 AMU. Are you following? Good. I hope everybody is getting it from the periodic table. Now, if I have, what's the mass of one molecule of H2SO4 in gram? What should you do?
Divide by Avogadro's number.
Divide by Avogadro.
It's the same number, 98.086. What's the unit? AMU, and change to gram. How?
Multiply by 1 gram, divide by Avogadro's number in AMU.
By 6.022 times 10 to the power 23. And what's the answer?
1.628 times 10 to the power 22 minus 22.
28
Times 10 to the power minus 22.
22. What's the unit?
Gram.
Gram.
Gram of H2SO4. But this is the mass of what?
One molecule.
One molecule.
Doctor, in the first one, isn't it the mass of 1 mole?
No, the AMU is the molecule. Now, what's the mass? Mass of 1 mole of H2SO4. What is the 98.086. But what's the unit?
Gram.
H2SO4. Is this clear?
Yes.
Doctor,
Yes.
Yes.
if we want to get the mass of one molecule of, let's say, NH3, instead of dividing by Avogadro's number, can't we multiply by the mass of one proton or neutron, and we'll get the same answer approximately?
Are you going to add the exact all the protons and the neutrons, all of them available in N and H?
But if we multiply by, let's say, the weight of the
Yes.
mass of a
Yes,
proton, we're going to get to the same number.
of course. Of course.
So we
Now,
can use that, right?
you can use that, but it will be very difficult, extremely difficult, because you need to, and this is for isotopes only. But I mean, if I give you NH3 in general, which molecule you have to take the average of the mass of, I mean, we have more than, for example, hydrogen. We have 1, 1, 1, 2, and 1, 3. These are isotopes of hydrogen. Which one you're going to take? Which hydrogen?
Aren't we going to take the average atomic mass from the periodic table?
The average, then you have to use the periodic table. You cannot use the one that you're saying, I want to calculate all the protons and the neutrons and add them together.
Oh, so it's pretty much impossible.
It will be almost impossible. You can do it, but it will be almost impossible. Is this clear? I hope this is very clear. You have to differentiate between these things. Good.
Doctor, what's the difference between the first one and the second one?
Which one?
The mass of one molecule of H2SO4 is 98.086.
Yes.
Then, didn't you say the same thing for the second one? Or am I reading wrong?
No, mass of one molecule of H2SO4. But what's the
Okay.
unit?
This one is grams. Okay, thank you.
This is gram and this is AMU. You have to be careful. The unit is important. Clear?
Yes, thank you.
Okay, good. Now, chemical reaction. When we have chemical reaction, we usually like to represent it by chemical equation. What do I mean by chemical equation? We write things like this. For example, we like to react NH3 with HCl to make NH4Cl. We call these as what? What's the name for these compounds?
Chemical reactors.
Reactant.
Reactants. We call these, if there are more than
Products. Products. Yeah.
product. Okay, we call these what?
Reactant.
Reactant. We call these
Products.
product. Very good. Reactant and product. We call these
Reactants.
and these
Products.
products. Now, next. When we have chemical equation like this, we want to make sure, by the law of conservation of mass, we want to make sure if there is any atom in this side, it must be available in the product. How many nitrogen atoms do we have here in the reactant?
One.
One. And how many do we have in the product?
One.
One. How many hydrogen? 3 plus 1, total 4. What's the label on the product?
4.
4. How about Cl? 1 and 1. We say this is already balanced. Balanced. Okay, how about the second one? Is it balanced?
Yes.
Yes, there's 1 calcium, 1 calcium. 1 carbon, 1 carbon. 3 oxygen, 1 and 2, 3 oxygen, This is already balanced. Good. How about this one? Is it balanced?
Yes. Yeah,
One
brother.
hydrogen,
Yes.
two hydrogen. One sulfur, one sulfur. Four oxygen, and this is balanced. Okay, good. All right. So we also like to write in the chemical equation. We like to write the physical state. What's this word?
Gas.
Gas.
This one.
Gas.
Gas.
This one.
Solid.
Solid.
This one.
Solid.
Solid.
Solid. Solid.
Solid. Gas.
Gas.
Solid.
Solid. Gas.
Gas.
Solid.
Gas.
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 What's
Liquid.
this?
Gas.
Liquid.
Aqueous.
This one.
Aqueous.
Aqueous.
Aqueous. Aqueous. Liquid and aqueous. Very good. You have to know this. Next. We have here two compounds, which is carbon, graphite, and carbon, diamond. What did we call them? From chapter 2, we have a name for these compounds.
Allotropes.
Allotropes.
We call them allotropes. What's the meaning of allotropes?
The same atom but different forms.
A compound consisting of one atom, but it's two different things. Do you know what's sea graphite?
A pencil.
Pencil.
Pencil head, which is the black thing in the pencil. The black thing, black thing that we write with is actually graphite. Do you know what's diamond?
Yes.
Almas.
Expensive jewelry.
The joke.
Jewelry. Very expensive. See, it's consisting only of carbon. Graphite, what we write with is just carbon, and also diamond consisting of only a carbon atom. But you know that graphite, if you want to buy a pencil, how much will it cost you to buy 10 pencil together? Well, how much will it cost you? Maybe 10 riyals? No, 10 riyals even. Okay, how about if you want to buy 10 grams of diamond?
Maybe 500.
Thousands of dollars. All right, clear? Okay, I just want you to know, don't forget the word allotropes. Allotropes. All right.
Doctor,
Now,
is it a compound or an element? Graphite.
This is compound. It's
Okay.
elemental compound. Only one element, elemental compound. Only one element.
Okay.
Both of these, yes,
Yeah, you can continue, sir.
yeah. Both of these, when we react with oxygen, they will give the same product because they are carbon with oxygen, and this will give you CO2, and this is CO2. And are they balanced?
Yes.
Well, the second one.
Doctor, the difference between these two are the percentage of the element?
No, no, how the structure is. In the first one, we'll take this in chapter 9, how is the structure difference between them. And this is in chapter 9, not now. We'll talk about it later on. But they are different. They consist only of carbon, but how the carbon is arranged is different. In graphite, for your information, the carbon is arranged like this. Okay, and this is continuing everywhere. In diamond, the carbon is arranged like this. And everything is carbon, carbon, carbon. how the atoms are. This is diamond and this is graphite. We'll talk about this in chapter 9. Don't worry about it. Good. Let's have H2O2. We know that H2 react with water to give you H2O. Is this balanced?
No.
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 Balanced.
No.
2H2.
You multiply this by 2.
So we have 4 atoms.
And this by 2.
And the product by 2. Yeah.
Is this balanced now?
Yes.
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 Good. Okay, good. Okay, let's try with this one. Let's see how good are you now in balancing equation. Let's try C4 H10 O2 to go to CO2 plus H2O. Is this balanced now?
No.
No.
By the way, when we say combustion, what's the meaning of combustion?
Any organic.
What's the meaning of combustion? Burning
With oxygen.
With the oxygen, yeah.
with oxygen. That's the meaning of combustion. So we are now burning C4H10 with oxygen to make CO2 and H2O. Can we balance it? Always, when you want to balance, start with all the other atoms except oxygen, except keep oxygen at the end. How many carbons do I have on this side?
4.
Sure. What should I put here?
4.
It should
Why?
yes.
Fine. Because now carbon is balanced.
Balanced.
How many hydrogen do I have on this side?
10.
10.
10.
Put 5.
Right here.
Put
here.
5.
Fine. Very good. Now I'm done with hydrogen and carbon. How many oxygen do I have in this side now?
You have
13.
13.
13.
13 plus 5, which is 13. And this side,
Only 2.
so what I'm going to do, I will multiply this by 13,
Over
divide.
2.
If I multiply 13 by 2, divide by 2 times 2, what is the answer going to be?
It's going to be balanced.
13. So is this balanced now?
Yes.
Not yet.
No, it is balanced. But we don't like to have fraction in chemistry, chemical equation. We don't like to have fraction. How can you get rid of the fraction?
Multiply by the whole by 2.
So what will be, when I balance it, is it going to be what?
It's
2C.
Yes, and then here, what should I put here?
13.
13.
And I should not put 4 here. What should I put here?
8.
8, and here?
10.
10.
Can you balance things now, like this way?
yes.
Yes.
So why do you divide 13 by 2?
13 by 2 to make it
13
by 2 times 2 is equal to what?
6.5 times 2 is 13.
13, which is I have here. I have 13 altogether. If you multiply 4 times 2 is 8 plus 5, 13. So I have 8 plus 5 equal to 13. I want to make this side also 13. I multiply by 13, divide by 2, get rid of 2 with 2, and this way you get 13. That's what I did. But we don't like to have fraction. I multiply everything by 2 to make it without fraction.
Yes.
Now, how many carbons do I have in both sides?
8.
8 in this side and 8 in this side. How about hydrogen? How many hydrogen?
20.
20 in this side. And how much is this one?
20.
20. Okay, how about oxygen? Well, how much do I have in this side? 26.
26.
How about here?
26.
I have 16 in this side plus
10 atoms.
10, which is total
26.
is this balanced. Is this balanced?
Yes, it is.
Yes.
And that's how you do it. Good. And that's the answer. Good. All right. Let's balance this equation. Now, before I go into this, what's this group?
Hydroxide.
Hydroxide.
Also the charge, hydroxide. As I said, in table 2.3, you must memorize and memorize very well. How about this group?
Perchlorate.
Perchlorate.
Yeah.
When we want to balance things, we can balance things by two methods, either by each atom by itself or by the whole group. We can make the whole group, okay? So in order to make things easy for me, I will use this as a full group. Full group. So I want to balance this equation. So what I'm going to do, I have how many BA in this side?
One.
One. So still one here. Is it balanced?
Yes.
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 How many perchlorate do I have in this side?
One.
One. How many here?
Two.
Two.
8.
Two.
Two, sorry.
Not 8, 2. Because I will use this as one group. So I have 2 of them. So how can I make this balanced?
Multiply by 2.
Multiply by 2.
2. Okay. Now, did I do anything with the barium? Nothing. Now, how many hydrogen do I have in this side?
Two.
2. And how many in the reactant?
2.
9.
4. Okay. How can I make them 4?
Multiply with 2.
Multiply by 2.
H2O multiplied by 2, exactly. Now, what is left is the oxygen. How many oxygen do I have? Should I calculate this oxygen?
No, you can't.
Why? Because I use it as a group.
Compound.
Yes. Now, how many oxygen do I have in the reactant?
2.
2. And how many in the product?
2.
2. So I can do that. I can also do that. Okay, but can I do it the other way?
Anyway, this will work.
It will work, exactly. Let's do it one more time without the group.
It's the same thing, but it's going to be more complicated.
Yes, of course. It will be more complicated. That's it. We'll start with BA. 1 here, 1 here. No problem. Okay, let's go to chlorine. 1 here, and how many here?
2.
2. So how can I make it 2?
Multiply
Multiply by 2.
By 2. That's it. Now, finished. How many hydrogen do I have in this side? In the reactant?
4.
2 and 2, 4. How many in the product?
2.
2. Multiplied by 2 to make it 4. Good. I'm left with oxygen. How many oxygen do I have in the product?
10.
Total.
10.
2.
How
9.
many oxygen?
10.
10 oxygen. 10 oxygen. How many do you have in the reactant?
10.
10.
I have 2 here and 8 here. Also 10 oxygen. So it is balanced. So this is the balancing. So which way should I use? The first one or the second one? It's okay.
Always the first one.
First one is faster, let's say. but you have to be careful not to mix things. You have to deal with the group as a whole group. Very good. Now, very quickly, balance this equation. You do it. Help me. Okay, let's do it. What's this reaction called? What's the name of this reaction?
Combustion.
Combustion, don't forget it. Okay, what's the first thing I will put here this side? Carbon.
4.
Multiply by 4.
4 on the product.
Multiply by 4.
Hydrogen. Keep always the oxygen last thing. Hydrogen. What should I write?
Multiply the product by 4.
4.
Very good. 4. Good. Done with the hydrogen and carbon. How about in the product? How many oxygen do I have?
12.
12.
Well,
6.
oxygen. What should I do here?
Multiply by 6.
Multiply O2 by 5.
By 5.
By 5. By 5, doctor.
5. No, 5.
5. We have 2 on the.
We have O2 in first
See,
reactant.
everybody can make mistakes, of course. Yes, of course. This is wrong. Why? I did not put in my mind. I forgot about this one. That's why when you deal with groups, you have to be careful, because that's what will happen. You will forget about the whole group. You will concentrate only in this one. So this one we must multiply by only 5. Why? Because this is 12, and there were 2 here, and I need 10 here to make 10 plus 2 is equal to 12. And now it's balanced. Is this clear?
It's combustion.
Doctor,
Yes.
can I divide before I divide by 2?
You divide by 2. If you have the most important thing, you don't have to have fraction. I don't want to see fraction. You can write if you have when I made this one 13/2 to make my life easy for a short period of time. 13/2, the 2 will go with the 2 and will be left with 3. And then I multiply everything to make everything in whole number. You cannot have fraction. Is this clear?
Yes, okay.
Very good.
Yes, but how do we decide which group to balance first?
Always start with whatever except with oxygen. Oxygen, keep it the last. Or if you have an atom that's available in more than one place. We'll have some examples. Good. What is this number?
Avogadro's number.
Avogadro's number. We were represented by Na. I want you to memorize the name, Avogadro's number, and the letter. What's this letter? What's this symbol?
Avogadro's number.
Avogadro's number.
Avogadro's number. Is this clear? Okay. Okay. The Avogadro's number is the definition of a mole. So if I say 1 mole of anything, is equal to what? Na of that thing. What do I mean? If I have 1 mole hydrogen atom, how many? How many is this?
6.022.
Times 10 to the power 23, and then what you should say?
Hydrogen atom.
Hydrogen atom. Clear? If I have 1 mole of H2 atom, how many is this? 6.022 times 10 to the power 23. Should I multiply this by 2?
No.
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 Atom.
Because the unit is different now. This one is called H atoms. This one is H2 molecule. Oh, I also made a mistake here. So if I ask you now, what's the 1 mole of anything, you should always answer me what? Avogadro's number of the thing that I'm asking about. Clear? So if I say 1 mole rain drops, what's this equal to?
6.022 times 10 to the power 23 raindrops.
What? Rain, yes.
Drops.
Drops. You must keep the same units. Okay, is this clear? Good. 1 mole of O2 molecule. O2 molecules equal to what?
O2 molecules
6
times
Avogadro's number. Multiply by 10 to the power.
Oh, 1. Yes.
Isn't it like 32 grams, 1 mole equal to 32 grams?
We did not. We're not talking about Avogadro's number. Of course, it is equal to that thing. Let me take this away now. I hope this is all clear. Good.
Yes, it's clear.
Okay, good. Now, let me give you another example. If I have 1 mole of H2SO4 molecules. Okay. 1 mole H2SO4 molecules. Then this is how many molecules?
6.022 times 10 to the power 23.
What?
Molecule.
Write the whole name. H2SO4 molecules. Clear? Now, if I still have 1 mole of H2SO4 molecules, how many S atoms are there? S atoms are there?
Uh, 6.022 times 10 to the power of 23.
Is this clear? Clear?
No.
Yeah. Doctor?
No.
Yes, just a second. I did not finish. Let me finish and then ask me. How many hydrogen atoms are there?
6.022 times 10 to the power of 23.
Times 2.
Times 2.
Times 2.
Yes. Times 2. Yes. 2 times 6.022 times 10 to the power 23 hydrogen atoms. Clear? How many oxygen atoms do I have?
Times 4.
4 times 6.022 times 10 to the power 23 oxygen atoms. Is this clear? So I'm doing the same thing, but I change the units. Here H2SO4 molecule. Here S atom. I took only the S. It's the same number, but I took only the S in this side. Okay. Now, how many hydrogen atoms do I have?
2.
2 times Avogadro's number. How many oxygen atoms do I have?
4 times Avogadro number.
4 times. Okay, same thing if I want 1 mole of H2SO4 and I want to know how many total atoms. What is it equal to?
7 by 7.
Yes, what?
By 7. 7 by Avogadro number.
0.022 times 10 to the power 23 total atoms. Is this clear? Is this clear?
No, Doctor, what's the last one?
The last one?
Yeah.
The last one is the question of how many atoms of hydrogen do I have? 2. And how many sulfur?
1.
1. And how many oxygen?
4.
4 plus 2 plus 1.
But they are not equal. So
Not
you can count them.
I'm not saying equal. They are not equal. Total atoms. I'm counting atoms.
Okay.
Is that clear?
Yes.
Very good. Let's have some other example.
Doctor,
Yes.
in this example, H2SO4, can I say that the amount of oxygen is 4 times greater than the amount of sulfur?
No, in numbers. Yes.
Doctor,
Doctor, you are muted, doctor.
We can't hear you.
Doctor, we can't hear you.
Can you hear me now?
Yes. Yes. No.
Yes.
So what's the answer, doctor, again?
In numbers, I'm saying it in numbers, how many in 1 mole of H2SO4, how many, or in the molecule H2SO4, for every sulfur, how many oxygen atoms are there?
4.
Yeah, that's what I'm saying. In numbers, yes, there are 4 oxygen atoms compared to 1 sulfur atom compared to 2 hydrogen atoms in the molecule.
But of course, not in the mass.
Not in the mass, of course. The mass is different.
Doctor,
Yes.
we don't have to multiply it with the mass number. We only multiply with Avogadro or what?
What do you mean by mass number? Don't use mass number. Use atomic mass.
Okay.
I'll give you some examples. Now, I want you to keep this equality in your mind always. 1 mole of anything, let's give something. For example, if I have, let's have something else. Let's say K or sodium chlorate. This compound is called sodium chlorate. 1 mole of sodium chlorate. How many molecules is this?
6.02.
You have to answer the same answer. 6.022 times 10 to the power
23.
23 what?
NaClO3.
Molecule. What is it? Na. You have to put the whole name. NaClO3. Clear? If I have.
Doctor.
Yes.
Why you put molecule, although it is an ionic compound?
It is well, a molecule, I mean the whole thing. It is, even if it's molecule compound, yes. Formula, it's formula molecules. Molecular formula. No problem. Okay, good. Now, if I have 0.25 mole NaClO3, How many molecules are these?
0.25 times Avogadro's number of molecules.
You have to write this equality. Always use this equality to get rid of units. What should I start right at the top?
1 mole.
No.
Avogadro's
number.
Down. Because I want to get rid of mole with mole. 1 mole in a ClO3, and should I write here 6.023 022 times 10 to the power 23 CnAClO3 molecules. This way I get rid of this unit with this unit, and I have the answer in molecules NaClO3. Is this clear?
Yes, doctor. But why we put 0.25?
That's my question. All right. If I have, let's have something else. If I have 6, or let me give a number. Okay. If I have now 3.23 times 10 to the power 19 H2O molecule. How many moles is this? How many moles?
It would be 1 gram over Avogadro's number.
So what should I write at the bottom, at the top?
At the bottom, one mole.
I will say at the top 1 mole. Don't forget to write 1 mole what?
H2O.
And down, what should you write?
6.020
6.022 times 10 to the power 23 what? H2O molecules. And this way the H2O molecule will go with H2O molecule, and you have the answer. Can you change from numbers to mole and from moles to number?
Yes.
Very good. All right. Okay. In our body, there are 30 moles of calcium. How many molecules of calcium do we have in our body? 30 mole calcium. How many calcium atoms do you have?
30 times Avogadro's number.
Don't tell me times Avogadro's number. What should I put at the top or the bottom?
At the bottom, 1 mole.
1 mole, exactly.
The top of Avogadro.
0.022 multiplied by 10.
Power 23 calcium atom. And I have the answer. Good. The other question, if I have 1.00 times 10 to the power 20 calcium atom, how many moles is this? I should write at the top what?
The bottom.
1 mole.
1 mole. Ca atoms.
The bottom of Avogadro number.
3.22 times 10 to the power 23 calcium atom. This way, get rid of this unit with this unit, and you have the answer. Is this clear? How easy? Good. Now, we also want to define now molar mass. Molar mass, which is, we represent it by M, but it's not a regular M, it's like this. This letter, I want you to memorize now. What is this called? Molar mass. Molar mass. What do I mean by molar mass? It's the mass of anything. H2O, what's the mass of H2O? We know it from the periodic table. Give me what's the mass of H2O?
18.008.
18.
mu.
0, 16.
2
16.
should say AMU if I say H2O. But if I say 1 mole of H2O,
Gram.
let's say gram H2O. This 18.02 is called molar mass. Molar mass. Very quickly, I want you to tell me what is this for an NaCl molecule. Quickly.
And 58.44.
Okay.
58.44. What's this? Gram.
AMU.
Gram. Good. Okay. Now I want you to keep in mind, very important, that 1 mole in ACl is equal to what? 58.44 what?
AMU.
No, 1 mole. Gram of what?
NaCl.
If I have 1.0 gram in ACl, can you change this to mole?
Yes.
How?
I multiply.
Divide by 58.
Divide by, I mean, multiply by what? 1
1 mole over 6.
in ACl, divide by?
Avocados.
No, not avocados.
No, I don't.
8.44 gram in ACl. Why did I use the molar mass?
Because you want the grams. 1 gram.
Good. Now, can you change number of moles to a number of molecules?
Yes, multiply by Avogadro's number.
Yes. Now I say 1 mole in ACl is equal, always 1 mole of NaCl equal to what? 6.022 times 10 to the power 23 what?
Molecules.
ACl molecules. And this unit, and I can calculate from gram to number of molecules. Is this clear?
Dixon, can I say that the molar mass equal to 1 mole?
Molar mass equal to 1 mole, of course. Molar mass is the mass of 1 mole. Read it. Read this one. The molar mass of substance is equal to what? 1 mole of the substance.
Yeah.
So yes. Okay, I'll stop here. Okay. Okay, I will also stop recording.
Mister,